Hello everyone. Today I will briefly explaining three important topics. So first one is principal component analysis. PCA is a deterministically reduction technique used to simplify data while preserving as much information as possible. The key idea is to transform the data into a new set of variables called principal components, which are uncorrelated and ordered by how much values they explain in the original data set. Here are the main steps. Step 1. Standardize the data. This means ensuring that each feature has a mean of 0 and a variance of 1. This step is important because PCA is sensitive to the scale of the data. Step 2. Compute the covariance metric. This metric shows the relationship between different variables in the data and helps us understand how the data variable together. So you could use the code of COV matrix to do this. Step 3. Calculate eigenvalues and eigenvectors. Eigenvalues tell us the magnitude of the variance, and the eigenvectors represent the direction of the variance in the data. So we use these two codes to do this. Step 4. Select the principal components. We choose the eigenvectors corresponding to the largest eigenvalues because this captures the most important information. So we first use this to sort eigenvalues in descent order, and then select the top k principal components. Use this, so you can choose whatever quantity you like. We here just use 2. And number 5, project the data onto these principal components. This reduces the number of dimensions while retaining the most significant information from the data. So project the data onto the principal component space. We use data PCA to do that. We use numpy dot. You can tab out the data standardize principal components in this. And number 2, data visualization. Data visualization is about creating visual representations of data to make patterns and insights more accessible. Let's look at a simple example, creating a scatter plot with a regression line. Scatter plots are excellent for showing relationship between two variables. In our example, we plot the total bill various the tab in a responded data set. We can use a tool like Seaborn to not only create the scatter plot but also add a regression line to observe the trend between the two variables. You can see first load the data set from Seaborn as an example, so we need to import this too. Second, use isonize.load to load the dataset. Step 2, set the style of the plot. We here use isonize.set and then create the scatter plot with regression line. So the important code is isonize.regplot, which will create the scatter plot. If you want to add title and labels, just use this 3, which is plt.title, plt.xlabel, and plt.ylabel. And if you want to display the plot, just use plot.show. Don't forget this too. It is very important. So machine learning algorithm can sometimes be slow, especially when dealing with large data set. One common way to speed up this algorithm is by using stochastic sampling, which involves using a small randomly selected portion of the dataset for training. For example, if you have a large data set, instead of, for example, if you have a large data set, instead of training our module on the entire data set, you can randomly select 20% of the data. This reduces the time it takes to train the module while still allowing it to learn the important pattern in the data. So, first step, we use Scottish sampling to select a portion of the training set. So we need to use those two from and create a static classification dataset, which use make classification, and then we'll choose 20% of the training data to speed the training process. So we use sample ratio and make the number to 0.2, and then if you want to initialize a random forest cluster, use random forest classifier. And if you want to train the module on the sample data, just use calf.feed. So this method is especially used in the early stage of module development when you need faster iterations to turn parameters or debug the process. Even if the training data size is reduced, the module accuracy remains reasonable, so it will helpful in the early stage. Thank you for listening.